Okay, so if you've been following along, this was originally a fidget 4-servo based hexapod. I basically figured out that wasn't going to work, in part because through USB the computer was having a hard time talking to more than 6 USB devices at once. Also, using 6 fidget servo controllers required that I build this, which originally had 6 servo controllers mounted on it with Velcro. It also required all of these little USB cables that I had to cut and splice, and it required this monstrosity, which takes the battery power up to 6 different power plugs. The robot's actually light enough that it can carry itself through a tri-gate. The tri-gate has to be pretty light, and you can hear some of the servo horns actually starting to skip already, and that is with just the weight. Now you notice that at times the lift servos don't get to their full lock position, and so that means I'm going to have to upgrade those. And I'm probably going to also have to upgrade the servo horns to full. I was having a failure in the servo, the shoulder servo in the 6th leg. After dissecting the servo, I found that the problem was actually that the gear inside the servo was stripped and not the servo horn like I had thought. I replaced that gear, and now the robot can actually move and support the laptop without making any of the servo grinding noises that it was making before. This is encouraging, but you can also see that the shoulders don't make it back to a full lock position, which means they're going to need to be upgraded. Okay, so to the what was originally a fidgets-based hexapod, which is now SSC32 based hexapod, I have added Wii Control. Now, I can't actually use the tilting sensor because it's too sensitive, and because you can't see the screen, the robot would tend to wander. So I basically have mapped the buttons to the different walking gates. Pressing home zeroes the hexapod or sends it back to a home position. Pressing forward makes the robot go forward. And home again centers it. What is really the down arrow makes the robot turn to the right. The up arrow makes the robot turn to the left. And I guess it would be the right arrow makes the robot walk backwards. Alright, I guess we're ready for automation now.